we'll look at a few issues in Chapter 17, looking only at sections 17.9, 10, and 11 on soil pollution and erosion. In 17.9, we'll consider soil erosion. Soil erosion occurs as a result of a number of processes that related to how humans use Earth's surface. The first change that we're bringing upon the surface is urbanization. Paving. All our streets lead to additional runoff, and the runoff is concentrated often in locations where the water is moving very rapidly, creating the potential for erosion. Desertification, or the overgrazing or otherwise disturbing the vegetation on the surface, can lead to drying up of that land and subsequent desertification and wind erosion. Deforestation. When a forest is overlogged or burned or clear cut, it leaves the remaining soil surface exposed to precipitation and the potential for erosion. Surface mining. In 2000, about 65% of all the coal being developed in the U.S. is coming from surface mining. So there's an awful lot of surface mining going on that promotes erosion. And soil erosion and deposition by hazards such as floods, as you see on the left, where I believe that Charlotte, North Carolina, after heavy rainstorms, and you see the sediment deposited that's been eroded from elsewhere. In the image on the bottom right, you'll see a gully formed in an agricultural field where the precipitation was great enough that it led to this type of gully erosion, which is a fairly advanced stage of erosion. It's very difficult to stop a gully from progressing once it's formed. Sediment is considered a pollutant and is considered a problem in many situations. First of all, it's our greatest pollutant by volume and weight. It can be choking waterways, burying vegetation, and causing additional dust storms. It also can have an adverse impact on water quality and air quality and land productivity. There are a number of preventative measures that we have been introducing into our land use practices, and some of those are more effective than others, and some are more or less are not universally developed, so it means that we have room for improvement. As a pollutant, sediment can be, of course, is our biggest issue in volume. But sometimes there are situations where not having sediment in the water is a problem. For example, in Louisiana, the sediment that had been coming down the Mississippi River was always resupplying land that was experiencing subsidence off Louisiana. The consequence is now is that subsidence is progressing, but the sediment that would fall on that land that came down the Mississippi River isn't. It's being trapped up behind reservoirs in the Missouri River, the Ohio River, and the Mississippi River system. So because the sediment is getting trapped upstream, it's not being delivered to Louisiana. This kind of sediment feeding the mouth of a river, as you see here, is excessive. But when that process is part of a natural system, like it had been in the Mississippi River system for many years, stopping it is also a problem. Look at section 17.10, land use and soil problems. If we look at agricultural lands across the globe, it's estimated that about 10% of the world's best agricultural land has been damaged due to soil erosion and overuse of those soil lands in the last 50 years. To try and use more sustainable agricultural practices, there are a number of techniques that have been introduced that are useful to try and prevent this problem. The first is contour plowing. The next is no-till agriculture, that is no plowing whatsoever, so that the vegetation from the previous year's growing cycle helps to prevent erosion while the next crop is coming in. Other steps are terracing slopes or using retaining walls for a steep slope. And lastly, planting more than one crop, particularly in tropical areas. Here's an extreme example of the contour plowing so that you can see the contour farming occurs in strips along the where each furrow is at approximately the same elevation, and you're not going plowing up and down the slope, you're plowing along it. This helps reduce erosion. Well, I had also mentioned terraced slopes, and here's an example of a terraced slope being used in agricultural production. Some of the land use and soil problems that we have come from urbanization. When we've converted agriculture, forest land, or other rural land into city lands, then we're adding a bunch of pavement and promoting the increased chances of erosion. In this situation, we will often scrape off the topsoil, and it will completely lose that topsoil because it's just being disregarded, and it actually is a resource of it in and of itself. We'll also have a change in the soil properties. When we strip off the upper layers, we'll have different soils exposed that had not been exposed to the surface before, promoting the potential for erosion. We'll also introduce a number of different kinds of pollution sources, the use of chemicals to feed a lawn, pet waste, and other changes in how we're using the surface can create potential pollution sources. We'll also have changes in surface runoff, sediment yield, and stream dynamics that affect soil and soil erosion. That come from how we use land might come from off-road vehicles. When we have recreational industries or tourism that's very active in an area, it can be problematic. In deserts and coastal sand dunes, whether it's off-road vehicles of one sort or another, or such things as snowmobiles in some areas, can cause significant damage. These can cause changes in the rate of erosion, in the hydrology, and in the habitats of plants or animals. In beach areas in Massachusetts, we have this type of sensitivity as well. The impacts of the off-road vehicle use has affected a number of mountain bikes and parks and national forests. And if you look into Yellowstone National Park, for example, you'll see there's a very sensitive issue about how all-terrain vehicles and snowmobilers are allowed to use their equipment off roads. This is the type of potential damage area where sensitivity to off-road vehicles can be intense. And here's an example of that kind of activity, looking very fun, but also offering the potential for significant damage to any vegetation at the surface that had been helping to stabilize a slope. Mining and its impact on erosion and other surface pollution issues. Past mining practice has been particularly destructive. In surface mining in particular has a strong environmental impact on our soil systems, and it completely removes them. And in past practices, we often gave no regard to the environmental impact of that disturbance at Earth's surface. And often mining companies, once they had extracted the resource they were after, would abandon the land, leaving it with final void, leaving it with an area with little to no vegetation, with the potential for significant erosion and other negative environmental processes at the surface. But modern or responsible mining practice has environmental considerations built into the entire project, particularly with steps that involve work ahead of time and after the mining. First, before any mining would begin, more responsible mining practice would be to collect all the topsoil and preserve it, set it aside, and hold it for use at the end of the project. The mine work looking to reduce its impact on the environment would also fill in any final holes or openings and make sure that only stable slopes remain. Finally, the last step would involve replanting vegetation to restore some sort of stable ecosystem at the surface and monitoring to ensure that a relatively stable new surface remains after the mining process is over. That's a more environmentally sensitive method of mining, but some people go so far as to call it a sustainable mining practice. It isn't. Sustainable mining practice would have to leave resource behind, and it doesn't. But it is more sustaining of the ecosystem at the surface. But in terms of the fact that there's the permanent extraction of the resource in mining, it still isn't really something that you can consider a stable mining practice. Pause for some quiz questions. What fraction of the world's agricultural land has been damaged by soil erosion? The answer is about 10% so far. Which of the following methods is an example of an agricultural practice designed to reduce soil erosion? The answer is contour plowing. Topsoil at a mine site in modern environmentally conscious practice is removed and stored for use during restoration or remediation of the land after the mining is completed. Our last section is 17.11, looking at soil pollution. Soil pollution would occur as a result of any materials that are detrimental to human or other living organism being added to the soil. These would include organic chemicals, inorganic chemicals, or other toxic substances. They might be intentionally or accidentally applied to the soils. They may result from the inappropriate disposal of waste materials, or what practices we had in the past might now be called inappropriate. Our treatment of this type of soil pollution problem, and I've helped to train hundreds of professional engineers who work in this area. Our treatment options are relatively few. We have some methods that try and treat it in place, but mostly we have to excavate it out, remove it, dispose of it in a landfill or incinerate it, that is, burn off the organic content. And we do have some new methods in bioremediation that are in use, and one of the most common is to simply treat polluted soil at the location by excavating it, placing it, so digging out the soil, placing it on top of tarp or other impermeable barrier, adding fertilizers to allow the biological activity that would naturally occur within the soil to progressively eat up the organic content. And that works for some. So bioremediation can be used for some soils, but still it's an expensive and disruptive process. You couldn't be using the land while it's under treatment for 6 months or 12 months. Figure 17.22 shows an image of a relatively novel technique that has been used in some places and in some applications to try and promote bioremediation of polluted soil without having to excavate it, that is, without having to disturb it, to simply drill into it and circulate fluids and gases to try and promote the bacteria in the soil to break down some of the pollutants. Not all pollutants can be addressed by this method, and this method is not necessarily effective in many soils because we tend to have non-uniform distribution of soils, so this can work in part of a contaminated area and not in others. So it's not really, it's not our normal method of treating soils that have become polluted, but it is something that we're using in some applications and trying to find better techniques not to have to disturb the soil so much.